Today we are going to do another question, which is check the correctness of a relation rho is equals to 3g by 4 pi rg. So this is our relation where rho is the density and g is the acceleration due to gravity. R is the radius and g is the universal gravitational constant. So we have to check the correctness of this relation. So let's solve this in another page. So it's like a brand new start. So we know that it's given that rho is 3g by 4 pi r by g. So here the dimensional formula of rho is it is ml minus 3 because it is mass per volume, and the most common formula of volume is L cubed. And next, the dimension of g, which is acceleration due to gravity, is the same as that of acceleration, which is Lt minus 2, since acceleration is length over times this velocity over time, or length over time squared. And now similarly, the dimension of r right here will be L, since r is the radius, which is the length. And finally, the dimension of universal gas constant can be found by using the formula F equals to gmm by r square and isolating g, so which you will get m minus 1 L cube t minus 2. And obviously the other terms, let me write this in another color, such as 3, 4 and pi are dimensionless. If you want to write, you can write it, but it's not necessary. So now if this relation is correct, the dimension of LHS must be equal to the dimension of RHS. So let's do that. Now the dimension of LHS is the dimension of rho, which is ml minus 3, and similarly the dimension of right hand side RHS is the dimension of 3g by 4 pi rg. So let me add the brackets to make it pretty. It's supposed to be square brackets, but I'm making round brackets, don't mind it. So here 3 does not have a dimension, g has a dimension of Lt minus 2, 4 and pi does not have a dimension, r has a dimension of L, and g has a dimension of m minus 1 L cube t minus 2. So that's the dimension. So now let's do some quick calculation to see what we get. Let's see. First of all, let's find mass. There is only one mass, which is m to the power minus 1. Going up, it will be m to the power 1. Similarly, let's look at length. There is here this length and this length can cancel out, which means the length will be minus L cubed. And similarly, the time and time also cancel out, so this will be our result. So if you see, the dimension of LHS and the dimension of RHS are equal. So we can conclude it by writing, since dimension of LHS is equal to the dimension of RHS, we can say that the given relation is dimensionally correct. It may not be physically correct, but it is dimensionally correct. So in the next video we are going to do another question as well. So bye bye.